Welcome to Every Animal Has an Owner, a mostly large animal podcast for veterinarians and the people that depend on them.
There's basically three ways that we create vaccines that you will see in the field. One, we can take a weakened version of the disease-causing agent and use that to transiently infect an individual, giving them a simulation of a weakened challenge that allows their immune system to respond and to clear that, but be protective against the full strength version when it shows up. Smallpox is the classic example of this. What we now know is that's because the key targets that you need to have protection against in the smallpox virus, those few proteins on the cells on the virus surface that allow it to cause infection, are conserved between the cowpox and the smallpox virus. But cowpox can't replicate and cause serious disease in humans. Smallpox can. So by using that, we can expose and generate immunity that protects against smallpox, and that's what Jenner did. We call these modified live vaccines, and there are a number of licensed products in the field on that. They have their advantages and their disadvantages. The primary disadvantage is it's alive. And so one of the biggest problems with modified lives, particularly when used at herd level immunity in animal production systems, is the potential for those live viruses to either what we call revert to virulence, meaning that they can lose their ability to be weakened and they can start getting nasty, or they can recombine and you can end up with a hybrid between the vaccine and the native foreign organism. Then you end up with new strains. Now let's talk about a different one. It doesn't really matter. Let's talk about bovine viral diarrhea virus. Grow that in the lab, grow it up to full strength. Then we can kill that virus. We can kill it using chemicals. We can kill it using heat. It doesn't matter, but it's now dead. So all of the proteins, in theory, that are part of that virus are still there. We can use that to vaccinate. And so the trade-off between live and a killed product like that is that the killed product, usually we have to have 2 doses. You have to have that booster. The advantage is it's safe. It can't revert to virulence. It can't recombine because it's dead. However, it still has all of those proteins. And recall, all we care about are the specific proteins that are necessary for allowing that virus to cause disease in the cow or in the pig or in the human. So we're giving it everything. Then the third way you can do this is you can use the subunit approach, which is what Medgene does. So Medgene, we now have enough science in our rearview mirror because of the last 50 years that we know what the targets are. So for example, in coronavirus, as everybody probably has heard, we know that the spike protein on the surface of the coronavirus is what allows it to get into the cell and cause infection. So if we produce just that spike protein and use that for immunization, then we can mount an immune response against coronavirus that will prevent that coronavirus from using the spike protein to get and infect the cell. We can provide protection with just that protein. For influenza, we know it's something called the hemagglutinin, the H part of that H5N1 or H1N1 that you hear about. If we mount an immune response against that and get antibodies against it, we can block influenza infection. And that's in fact what we do. So we refer to these as subunit approaches because it takes one protein. And we make these proteins in the lab. We use an insect cell system, which means there's no animal products in it, so there's no threat of contamination. The baculovirus, which we use, cannot infect mammals of any kind and cause any kind of a disease. It's an insect virus, so that's it. And on top of that, because it's protein only, we actually put it through a killing procedure before it goes out the door.